Hello there. I wanted to start this unit by looking at an old problem that we saw from the previous year, going through it, solving, asking similar questions, but now using the vocabulary from our current unit. So this is one of those projectile problems. We're throwing a ball, upward velocity 32 feet per second from 48 feet off the ground. I need a function for the height, and we know that height depends on time, so I'm going to use my new function notation. H of t, for height dependent on time. Constant's the initial height. Now I have the linear component, the velocity, and gravity pulling us down. Now I can also graph this, so I'll plug it in my calculator, replacing t's with x's. Alright, so I can see here that the ball is hitting the ground at the 3-second mark, and I can check this stuff in my table. We're doing some new stuff this unit, so I said this was a function, but let's actually verify that it's a function. Is height a function of time? And I can look at the rule here, I can look at the graph over here, but for any point in time, there's only one height that the ball's at. 2 seconds, we're up over here, 3 seconds we're here, 2.5 seconds we're here. There's no time that has multiple corresponding heights to it. So height is a function of time. Another way to talk about that is that it passes the vertical line test. If I imagine shifting a vertical line left to right here, that line is only going to intersect the point of the graph once. If I switch this around, however, and ask the other question, is time a function of height? Then my answer would be no, because I can see in here that there are some heights for which there are multiple times. So we're going to ask this a bit later with the 60 feet one, but there are 2 times that are associated with that 60-foot mark. So not a function in that direction. This time the test, because I'm reversing things, would be a horizontal line test. And sure, down here it's only intersecting once. Actually, I guess twice, because that would extend down. But there are some heights where boom, boom, it hits twice. So I got to reject on that one. Vast majority of the time we're asking this way. Is height a function of time? Boom, it hits it once. Okay, when does it hit the ground? I see that it's at the 3 mark. How can I talk about this in function notation? So we're looking for that value of t that hits the 0. And I see that sticking in a 3 into my table is going to do that. So that's when it hits the ground. As for when is it 60 feet off the ground, I'm looking for h of t equals 60, and on my graph over here I can draw in that line, and I'm looking for these points there where it intersects. Now we are going to go through this algebraically later on where I set up the equation, but right now I can just look in the graph, look in the calculator, and I get 2 solutions, so half a second and 1.5 seconds. The very last thing to do here is to talk about domain and range. Going off of the rule up here, there's any value that I stick in for the time is going to spit out some height. Now, whether or not it's in the picture is another question, so this gets into our theoretical versus experimental. But I can stick in any t into this equation, and it's going to spit something out for that h of t. So there are no limitations. Every real number is going to work for our domain, at least in the theoretical. The range is interested in the y's. Now this is you have to imagine this keeps going, but there is a maximum. I need to know where that is. I'm pulling this from a table. We could, of course, get it differently. So I need to know the range. Now remember, for the theoretical, you have to know that this graph, this parabola, it keeps going, right? So it's going to go down to negative infinity, but it does have a maximum up here. And that maximum is 64. And it can be the 64, which is why it gets a hard bracket there. But we said that this is actually a problem involving a ball, so I want to actually ignore these lines over here. Just concentrate on what can actually happen. This is the experimental. For this one, the domain, the time, I'm not going to positive and negative infinity. I'm throwing a ball. It starts here at 0, and then boom, it stops when it hits the ground at 3. Range is a similar story. It's starting here at 45, goes up to the top that is going to get 64, plummets down to 0, hits the ground, stops. 48, doesn't need to be listed. So it's only this interval 64 down to 0, or change the direction 0 to 64. Alright, so that was a classic projectile problem from the previous year, but now we're talking about functions. Is y a function of x? Occasionally is x a function of y? Looking at this function notation. We'll do a lot of these solving things algebraically later, but just to get into the swing of it, we did it with the table. And also domain and range. Character and scholarship for life.